magnetic flux. So as we have seen in the electric field also, electric fields, we'll talk about the magnetic flux. Flux magnetic is equal to magnetic flux. Magnetic flux. What is magnetic flux? Suppose if a given area is given, if there is an area, say circular area, if there are number of magnetic field is from here to here, that is in this direction magnetic field is flowing, it means the number of magnetic field lines is passing perpendicular, passing normal to the surface. That is the number of magnetic field lines, the number of magnetic field lines that is magnetic field only, that is magnetic field. We can say magnetic field, it is a vector quantity passing perpendicular, perpendicular to the given area. The area may be square or rectangle or circle. Here we take a circular one. How many number of field line is passing through this area? This area is called magnetic flux, is known as magnetic flux. Is known as magnetic flux. Magnetic flux denoted by flux magnetic. So suppose we have here, this is the way magnetic field line, this is B, magnetic field line is flowing like this, and if theta, if it is means if this is the line, magnetic field line, this is the area, and this is area vector. What is area vector? Area vector is normal to the plane of surface. We must understand area vector. This is area is different and area vector is different. See, if this is the ring, if it is a flat disc and perpendicular to this surface is called area vector. This is the area of this one, and this is area vector, which is normal or perpendicular to the surface. So flux can be, we can define magnetic flux, the number of field lines passing perpendicular to a surface is known as magnetic field. Suppose if it is flowing, number of magnetic field lines flowing, and this is because it means the magnetic field lines is passing perpendicular to this surface. How many number of lines are passing through this area? That is called magnetic flux. Here magnetic flux. Now suppose if we have the plane is inclined at an angle, if the plane, the surface, if this surface, now it is like this, if the surface is like this, see the magnetic field is this way, we will take only one single line, magnet, and this is the way the surface is inclined, and its area is here, and its area vector is, this is area vector, because area vector is always perpendicular to the surface and making an angle of theta. That is, if theta is the angle made by the surface with magnetic field lines, magnetic field. See, this is the direction of magnetic field and the plane is in this direction and the angle between them is theta. So magnetic flux, so in this case how we will define magnetic flux? Magnetic flux is equal to area magnetic flux is equal to area into, not area vector, into component of magnetic field along A. This is known to be along A vector. Along component of, therefore the magnetic flux is a component of B along normal. Component of B along normal, we can say. That is along normal. See here we can say this is the area. This way the magnetic field is flowing, and this is the normal, that is A vector, we can say, our normal vector, and it is making an angle theta. Now if you drop the perpendicular to this one, this is 90 degree and this is theta, and this way, this is opposite side, this is base adjacent side, and this is hypotenuse. See here, the angle is always, the side opposite to this one is opposite to this, the side opposite to the angle is B. We will write this is B, this portion is B, and this is this component, this B can be converted into two components, one this one this one. One is away, so the hypotenuse into hypotenuse away from this angle means sine of theta, and this components B hypotenuse into cos of theta. See, in the trigonometry waves we must have seen, see, if this is theta and this is hypotenuse, this portion is H, this also hypotenuse, write the hypotenuse, this is this side is nearby, so here you will write cos of theta, this side is far away from the angle, this is sine of theta. Same way, this side is far off, so hypotenuse into sine of theta, and this side is hypotenuse into cos of theta. Now, what is the definition of magnetic flux? See, magnetic flux is the area, this is area of the surface, this is here is disk into component of B. So this is B, component of B. What is this? Is the component of B along A, component of B normal, B to the along the normal, that is A into, what is this portion? This portion, now you see, this is the portion that is B cos theta in this direction, this is B sin theta, sorry, it is A cos theta. If this is A, that is B sin theta, and this is theta, this is B. And if you drop this way, so this will be B sin theta. You have to be careful, use your trigonometry skill. Up, straight to the angle will be sine, and along by the side of it will be cos, and the hypotenuse into cos theta, hypotenuse into sin theta. So this is the component, along the normal. The component of, now you see, what is this component of A? That is, we have to write the area into component of B. This is B, component of B. If you drop like this way, this into component of B, this is B cos theta, and this is B sin theta, and here the component of B along normal. This is the normal, this is the component along the normal. So we can write B of cos theta. You have to be very careful in determining. So flux is equal to AB into cos theta. That is, magnitude of A is a vector, area vector, modulus of area vector is A, modulus of B vector is B, and this is angle. So flux is equal to a vector modulus of, we can write like this, A vector into modulus of B vector into cos of angle between A and B, or we can write magnetic flux. Magnetic flux is equal to modulus of one vector, modulus of another vector into cos of angle. It is nothing but dot product of both these vector. So we can write flux. Magnetic flux is given by dot product of A and B, which can be written as A B cos theta. See here, flux is here, scalar quantity, because dot product of two vectors gives you scalar. So it is a scalar quantity. Therefore, magnetic flux through an area A is equal to magnetic flux through an area A is equal to the vector dot product of area vector and the magnetic field vector B, which is equal to A and B. Suppose if the area is like this and this is the magnetic field, this is B vector and this is also area vector, because area vector is normal to the surface. If the surface is like this, this is normal vector. So the flux, we can write flux B is equal to magnitude of this one A and magnitude of this, and cos of angle between A and B. Angle between A and B is 0 is equal to A into B. So magnetic flux. So this factor become 1. So, and what is the unit of magnetic flux? A unit of magnetic flux is Weber. We have to remember, always it will be given Weber per meter square. So what is the unit of B? So from here B, what is a B? B is equal to flux, magnetic flux, that is B is equal to flux divided by area into area. Flux is equal to area, flux by area into cos of theta. This has got no unit. Therefore flux is, so what is the unit? B is equal to, flux is in Weber, area is in meter square. Therefore the magnetic flux is, this is called Tesla. So magnetic flux can also be given as Weber per meter square. In this numerical, a circular disc. So it is a circular disc of radius 0.2 meter. So radius is equal to 0.2 meter in an uniform magnetic field. So magnetic field is equal to 1 by pi. Magnetic field Weber per meter square. It is its unit, Weber per meter square, such that its axis makes an angle 60 degree. That is theta is equal to 60 degree. As it is, we know magnetic flux is equal to A dot B is equal to A B cos theta. So now this is the direction of magnetic field as per the given condition. This is the, and the disk is like this. This is area vector of the disk and this is its area, and this is making the normal, this we can call it as A vector or normal, making an angle of theta with this one. Now see here, this is B and this is normal vector. If you draw perpendicular to this one, and this portion is equal to B and this is theta, the opposite side, see, write the hypotenuse both the side, hypotenuse, this is the hypotenuse, this is angle, this is 90 degree, opposite side. Far away from the angle will become sine of this angle, by the side it will be cos of this angle. So we can write what is the magnetic flux. Magnetic flux is given as per this one is equal to modulus of area vector into modulus of magnetic field vector into cos of the angle between them. So area, what is the area? Area is equal to what is the area? It is a disk. It means area is equal to, it is a disk, its area is equal to pi into r square. So we can write for area of the disk is equal to pi. It is a pi into r is equal to 0.2 whole square into B. B is given 1 by pi Weber per meter square into cos of theta is equal to 60 degree. Theta is equal to 60 degree. If we draw the triangle for 60, it is 1 is to root 3 is to 2, and the hypotenuse, bigger side will be hypotenuse. This side, if this is 90, this will be 30, where 30 is there, put the root 3, then this is over cos 30 is equal to half. Therefore, this will become pi into 0.2 into 0.2 into 1 by pi into cos 60 is equal to half. Or this can be, this pi get cancelled. This can be written as 2 by 10 plus 2 by 10 into 1 by 2. This get cancelled, is equal to 2 by 100. See, since the flux is in Weber, so it is written as Weber. In short, it is written as Weber. And magnetic flux is Weber per meter square. Therefore, flux is equal to 0.02 Weber. The answer comes up to, the answer is this is the right answer. This appeared in 2008 NEET.